right, hello AP Statistics. Welcome. We're going to do some examples from lesson 2.2. Getting into our normal probability distribution, which we're just looking at now as just a normal distribution, and we're going to estimate percentiles location within this distribution. So first thing I want to do is draw this distribution. One way I could characterize this, right? We're looking at batting averages. Oh, wow, that was weird. I like to just put this here so that these numbers are available for me. Right, that's my mean and my standard deviation. Remember, it's always goes mu, sigma. And this is all the information that I need to actually draw this distribution, right? We're assuming that it's normal. Very important. Can't do this if it hasn't told me the distribution is normal or approximately normal. But since it said that, then I'm allowed to go ahead and, mark it down. I'm allowed to go ahead and draw my normal curve. Mr. Ghosty. My mean, right in the middle, 0.261. Then I'm going to go ahead and put values that are 1 standard deviation above and 1 standard deviation below. I'm going to do that by adding and subtracting my standard deviation. Like I said, I don't feel like mental math today. I'm going to go ahead and get out my handy dandy calculator. And then we'll do now we'll take it 2 standard deviations out. .295. Poopy. We're going to add 0.034. And then we'll take 0.227 and we'll subtract our standard deviation of 0.034 and we'll get 0.193 here. Last one we need to do is 3 standard deviations above and below the mean. So again, I'm going to add another standard deviation, 0.329 plus 0.034, 0.363 up here. And then 3 standard deviations below my mean is going to be 0.193 minus another standard deviation of 0.034 or 0.159. And there we go. That is what the distribution of batting averages looks like. So if you're being asked to draw the normal density curve, you're being asked for this. Show your mean and 3 standard deviations above and 3 standard deviations below. That's what's expected. Now it's time to get out that table of standard normal probabilities, aka I like to call it a Z table because it sounds cooler, I guess. No, I don't know why, because it's easier to say. Yeah, probably. What percent of the batting averages were above 0.329? Actually, let's do below first, okay? Let's do a B sub 1. And let's find what percent are below. And then we'll do above as well. Yeah, we'll do above as well. It's going to be kind of neat. It'll elucidate some cool stuff. There are two ways that I can do this, and I'm going to do it both ways. One is easy. Easy. You'll use technology and or the table. Actually, shoot, I'm going to show you 3 ways to do it, dang it. I'm going to show you how to solve this using the empirical rule. And then I'm also going to show you how to solve it using your table. And then we'll also get the solution with the calculator. So there are 3 different ways. Using the empirical rule. So our empirical rule tells us that, there you go, there's another one. That this has 68%, right? In this interval, we have 95%, right? Between 2 standard deviations and 3 standard deviations. In this interval, we have 99.7. What in the world? Why is my brain being dumb? There's no way that's a 7. Why am I thinking that? Okay. Myself. All right. So it turns out that this value of 3.29 is 2 standard deviations above the mean, right? Do I really want to use the empirical rule? It's the hardest way to do it. It's the most complicated way that you could do this problem. But it's good to see. But it's not fun. Because we got to do a bunch of like weird, like subtracting from the whole stuff. You know what I mean? In order to do this. So, all right. So let's look at this curve then in actual context. I know I'm going to move in a weird spot here and leave our empirical rule behind. But, okay, I'm going to draw this in a different way now. It's really nice to see. It's a good use of our time. Okay, so I can also break these up, right? That's 34, 34, yeah. And then out here, I'm going to figure out what these two are because it's going to be 95% minus, 95%, yeah, minus 68%, 27, and then we got to divide that by 2. Huh? So to figure out this, I'm going 95 minus 68, and I'm dividing it by 2. That's how I'm finding this. My brain's not good today. No, we're not using the z-square yet. We're just using the empirical rule. All right, so this one is 13.5. So this is 13.5. This one's 13.5. And then to figure out this last little piece of my normal distribution, right, I'm going to take my 99.7 and I'm going to subtract the 95 divided by 2. That's going to give me that one. I really am not feeling actual math today. But that's okay because we're strong. We persevere. What am I doing? 2.35. So this one is 2.35. So then all I have to do to answer this question, if I'm going to use the empirical rule, and some people really like this, okay? They see it, they have these values memorized, they just come up real quick. And if you're one of those people, that's great. Do it like this. 3.29. I was trying to actually answer the question. So 3.29 is right here. So I'm just adding this guy and this guy. So that would be 13.5. Wait, yeah. Plus 2.35. Or 15.87. Yeah, stupid. 15.85. And what we make that percent. Oh, I did above. Silly me. I was answering the actual B. Let's do below. Sorry. So if we're going below, my bad. If we're going below, then we're adding this one, this one, this one, this one, this one, and this one. And above we'll be able to get. You're going to be really surprised with how easy this is to do other ways, but it's worth looking at. All right, so what is that? 68 plus 27 plus 2.35. So that's better. So I did, in this case, for above. Below, I mean. Golly, why do I keep doing that? Below. We're going 68 plus the 27, right? So that's these and this. And then we're going to add that 2.35. And we're going to get 97.35. All right, cool. Let's do it now using the table. Okay, so now we're going to do this one using the table. We're still on B sub 1. So now we'll do with the table. So with the table, I'm going to need to find a z-score first. X minus my mean divided by my standard deviation. That's the empirical rule, or the 68, 95, 99.7 rule. Okay, now it's rolling off the tongue. I don't know why my brain switched numbers. Okay, let's do this. Let's find a z-score for this guy. We're looking for 3.29. So 0.329. Silly me. What in the world? My mean was 0.261. We're going to divide that by the standard deviation of 0.034. Get us an answer. That's a standardized value, right? This tells us how many standard deviations. It's going to be above, right? The mean this particular value is. Two. Hey. Doesn't that make sense? Right? The standardized value is telling me how many standard deviations above the mean that particular value is. Well, it's exactly 2 standard deviations above the mean, right? That's nice. It's nice when things kind of come together like that. I like it. Now what we do is we go to our handy dandy z table, and we're going to look for 2.00, okay? So I'm going to get that out. Boom, there it is. It's going to be on the positive side, which I wish I was feeling. It's okay. If I start singing a Jackson 5 song, you know it's bad. Okay. All right, where's 2? Oh, there it is. That's a little low. Let's go over, guys. Let's see. Well, I kind of need that too. Golly. We're going to leave it. So I am looking for 2.00. So I'm lining them up, and my percentile is 0.9772. So not as good of an answer. Or this is a better answer, I should say, right? Because what do we get? You're going to see our answers are going to get more exact as we go through different methods. Now, our calculator is going to give us an even more exact number. No, your answer will be slightly different because it's not. Because what's actually going on, what this table of values is a bunch of calculated integrals. Okay. And your calculator is actually calculating. So this gives you an estimate of the integral, right? Your calculator is actually calculating the integral for you. So you'll see. We'll get an even more exact answer when we do this in our handy dandy calculators. Here we go. All right, so let's go to our calculators. You can do this from your scratch pad. So I hit this calculator button right here. Since we're not putting in like a bunch of data and having to, define that as a variable, we can just make calculations in here, okay? All right, ready? Here it goes. You need to do this so many times this year. Okay. And I'll write down these calculator commands for you as well after we go through them. I'm going to hit menu. Now I'm going to hit probability. Okay. The only 2 we'll ever use is 5 and 6, probability and statistics. So I'm going to choose probability, number 5. And now I'm going to go to distributions, 5. And we're going to choose normal CDF. Never, ever, 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 ever use PDF. We'll never use it. It's weird. I don't even quite wrap my brain around what's going on there, but giving you a value at that value, not an area, which is not useful. Okay, so what we want is normal CDF. Now, our lower bound. Let's talk about this. If I am looking for an area, okay. Okay, told you. Okay, so over this way, my lower bound is negative infinity. Okay. So if I'm going from a point here, this direction, my lower bound will be negative infinity. This will be my upper bound. Okay. If we're finding an area from here, where this is my lower bound, then my upper bound is positive infinity. The third case, is that I'm looking at an interval between two values, in which case clearly this is the lower and this is the upper, right? That's what you're going to be putting in your calculator. So now in our particular example, our lower bound should be negative infinity, right? Because we're looking at everything less than that particular value. So our lower bound is negative infinity. Our upper bound will be 0.329. We'll put in a standard deviation of 0.034 on our calculator. Now, the calculator does not know what infinity is. What's weird is that actually the CX2s do. They will just, if you put infinity, there's actually an infinity symbol. You can put infinity as your lower bound on a CX2. On a CX, you got to just put a really, really negative number. If I have to put a really negative number in, it always starts with your lower bound. It assumes that you want to figure out a percentile, right? The number or the percentage below. So it automatically puts that lower bound. If I had to put it in, I would put, I hate that I can never find my negative sign here. Nope, that ain't it. There you go. I guess we can just use minus, huh? Oh, there it is. Thank you. That's better. It's good to use a negative sign instead of a minus sign. Some calculators will give you a syntax error if you... Yeah, you can put negative infinity in that. So I like to use... You can use the one that's in there, but that's the largest negative number that your calculator will calculate. My upper bound is 0.329. My mean was 0.291. 0.261, darn it. Flipped it. And this one was 0.034, right? All right. There it is. Huh? It didn't like your infinity sign? Huh. Last year, people with those calculators were doing it with infinity. Weird. You can even read this in this way. You don't actually need to. You can actually call up the command normcdf and just type in, this is your lower, this is upper, mean, standard deviation. Okay, always. They're always presented in that order. There are people that have liked to do that. They've liked to just call up the command and then type in the values rather than going through the menu that prompts you to put those values in. If you want to do that, that's fine. Back in the day, so with this calculator right here, when I had to do statistics with my TI 83 plus, that's what you had to do. You had to type in the command and know that it was in the order lower, upper, mean, standard deviation. You had to memorize a lot of calculator commands and things like that. These are nice. All right. Fantastic. 3 ways. Obviously, the last 2 are the best. They're most exact. But you can see, right, our precision, as we went through this, our precision for our answers increased, right? This has a higher amount of precision than the value that we got from the table. Okay. Okay. Wow. Are we ready to finally do B? All right. So for the actual B, the ones that are above, I am going to use the table, and I'm going to use the calculator. We're not going to use the empirical rule. Okay. Let's go. Above 0.329. So for B, let's look at above 0.329. All right, we already got a z-score for that, right? We know that at 0.329, we have a z-score of 2. At that point, Our standardized value is 2. But this is the deal. What my calculator gives me is, yep, my calculator is always, and the table for that matter, or sorry, the table, I should say, is always giving me this area, right? That's not the area I want. I want this area, right? All we have to do is recognize, right? Remember, any density curve, all of them, have a area of 1 underneath. The entire curve, the area is 1, right? So if I want to know what's left from this, so we got at this particular point, we said that was the 90, it was 0.97725, right? That's the area below. Yep. So then to get the area above, we'll just go 1 minus 0.97725. Yes. You just subtract it. Subtract it from 1 to get what's left there. You could as well. Yes, you could. So another way to do that. I love that. Let's talk about that. All right. Dang. You know what I kind of need today? Some sound effects. All right, so great thing to mention, right? Isn't it the same? Wouldn't I get the exact, if these are always exactly symmetric, right? Any normal distribution is exactly symmetric. That means that, where are we at? If I have the same location, so if this is 2 standard deviations below, and this is 2 standard deviations above, right? These areas are the same, right? So then, rather than, so I could see that we're 2 standard deviations above our mean right here. Well, then I could also find the area for this is a standard normal distribution, right? So I could also find this area. You know what I mean? They're in the same spot symmetrically to the mean, right? So let's do that. Let's go. Let's look at what our value is for -2. I hope that it's close to 0.0227. All right, let's look. Not that one. Let's find -2 on here. Whew. That's over here. Oh, yeah, -2. Boom, shakalaka. There it is. Let's use the calculator. Dang. So on the calculator, I'm going to hit menu, probability, distributions, normal CDF. My lower bound is 0.329. Upper bound is going to be infinity, positive. The mean was 0.261. The standard deviation 0.034. Right. There we go. Just trying to show you a bunch of different ways to approach this. It's very important that during this chapter, you get a really good firm grasp of this. Because it's coming back. Better to, refresh your memory on it than to try to learn it again to try to learn it the first time while we're doing something way more complicated than this. Okay. Um, okay. Oh my gosh. 45. I got time. All right. The next thing we're being asked for is what percent of batting averages are between 0.193 and 0.295? This one's nice for the empirical rule, right? Because 0.193 is right here. 0.329, right? So we're talking about between two standard deviations from the mean. So 68 plus 27. Or, yeah, 95. Right? Yeah, 95%, right? From the empirical rule. Done. So we're just going two standard deviations. So, I mean, I complicated it. Remember I said this one was 27 and that one, oh, yeah, was, yeah, sorry, 27. No, they're not 27. They're 13.5. The whole thing is 27. Yeah. Yeah. No, it's the 27 because this one's 13.5. This one's 13.5. The total is 27. Oh, I thought we were. Oh, then it's not as cool. Okay. Sorry. Not as cool. If it was two standard deviations, you could instantly say 95, right? But this one is going to be easier to do, in my opinion, using the table, or the calculator is really the way to go with this. The table. Oh, I got to find a z-score for each one. It's kind of a pain. We're going to do it. We have time. No, we don't. Yeah, we do? All right, we'll finish this one tomorrow. Because using the table to find in between, I have to find two different z-scores and then subtract. It's a little bit more complicated. All right, so now we'll look at C. C was asking for an area, or yeah, an area, the percent of batting averages between 0.193 and 0.295. So I'm going to go ahead and 193 and 295 is what it says. 0.193, 295. All right. So the first method I'll use is using the table. It's not the way that I would do it if I was given this question on a test. But I think it's really helpful for kind of seeing what's going on. So we're going to do it that way. And if you like it, then do it this way. That's fine. The thing about this is, in order to do this using the table, I need two different z values, right? Two different z scores, if you will. So the first one, I'll go for the 0.193. That's my value. I'm going to subtract from it my mean, which is, where can I find you? 0.26, standard deviation 0.034. Make sure that's all correct. Sorry for all the scrolling. 261 there, Cowboy. There we go. We'll get a z-score for that one. I'm just going to go ahead and set up the other one before I make calculations. I like to do things all at once. Like if I'm going to calculate, I'll calculate everything all at once. It's more efficient to perform all of one task at one time because of the time that it takes to transition from one task to another. I learned that when I was learning how to be a chef. I wasn't a chef. I was a cook. I learned a lot from this guy. He was like, no, don't cut one and then cut another. Like, do one cut, then do another cut. You know what I mean? I forget what I was cutting up. Something that required like more than one cut. You know, like a potato or something like that, right? So long story short, complete all of one process and then do the next is always the most efficient way to do things. Anyhow, we'll correct this little error here. Thank you for that. I used the other bound instead of the actual mean. Let's make some calculations right now. I get a z-score of 0.193. Oh, my calculator did not like that. 0.193 minus 0.261. The entire quantity divided by 0.034. We get a z-score of -2 here. And 1. All right, so we know that the value of 0.193 is 2 standard deviations below the mean, and that the value of 0.295 is 1 standard deviation above the mean. Let's go ahead and use a z-table to find an area that corresponds with this. So we'll have an area for this one, and we'll also have an area for this one. Let's try -2 on our z-table. There it is. And it's 2.00, right? So, so we're looking at 2. Make sure that we have that there. It's much nicer. So we're looking at -2.00, 0.0228. We'll get that one on there. Let's get the next one at +1. And it's 1.00. So we're going to still be looking at the same column. And that gives me an area of 0.8413. Oh, yeah, bro. All right. So in order to find the area in between the two, what's going on is a little bit of like geometry type stuff, right? This one gives me an area. This is this area, right? This one one standard deviation above is this area. So if I want the area on this interval, essentially, right, I'm looking for that area, and that's the same thing as right, this is this area minus that area, right? You know what I mean? If you want what's in between these, right? Subtract that little piece from this area, right? What you've got left is what's in the middle. Try to fill it better. This is what your calculator is doing, right? That's going to find the area below 2 standard deviations. Sorry, the area 1 standard deviation above, and subtract for it the area that is 2 standard deviations below. What you have left is your interval here, is this interval. An area. So let's see that. We've got those areas, right? We've got 0.8 So we got 0.8413 is this one. So now we can put numbers in. 0.8413 minus, we found out that this particular area is 0.0228. And that's our total area. Let's see, 0.8413. And I get an area of 0.8185. So that's how you do it with the table. Let's do it with the calculator. Yeah, 81.85%. That's right. The question did ask for an answer in percentages. Wow, we've done a lot. Percentage. Okay. Or 81.85%. Thank you for that. All right. Now let's get out our calculator. You're going to see how much easier that was. I mean, there was a lot of explanation that I was doing as I was doing that. So it did take a little longer, but it takes like almost no time doing it in your calculator. Only thing is if you're going to do it in your calculator, you still need to at least include, you still need to include this portion. So you're going to still need to show a z-score. The most precise way to answer this question is with a z-score. That way you can get a relative standing, right, or position in the distribution for each of those, and you get a position in the standard normal distribution. And then we put that into an area. Let's get out our handy dandy calculators. I'm just going to use my scratch pad because I can. So I am going to hit menu. We're going to go to probability. We're going to go to distributions. We're going to choose normal CDF. And now my lower bound is just what the bound that we were given, that 0.193. Our upper bound is the other value we're trying to find, 0.295. This was 0.361. 261, thank you, yes. And this was 0.034, right? Way less, right? I think it's less. But, you know, unfortunately, you do have to show z-scores at this point in time for these. It's always best to put more stuff on your answer as long as that more stuff is right. Unfortunately, an AP grader, if you put more stuff and that stuff's wrong, but everything else was right, they'll still dock you. So be careful. It's good to put more information, just as long as all that information's correct. All right. I think we did A, B, and C, didn't we? We sure did. All right. Let's do another one. You know what? I had not yet written down these calculator commands for you. So, areas in a normal distribution. By the way, this is always capitalized. It is a proper noun. Kind of weird. It's a specific distribution. Yeah, it's a proper noun. With TI and Spire. Make 50 cents every time I say that. Just kidding, I wish. All right. So I'm sponsored. It's pretty sweet. Sponsored by a calculator company? That would be, oh my gosh. How much nerd cred do you get for that? Like, I mean, I've been to an international calculator convention, so I'm close. But our commands are going to be use your scratch pad. So from the scratch pad, I recommend we're going to hit menu. we're going to go to probability. We're going to choose distributions. Then we're going to choose normal PDF, normal CDF. Oh my gosh. And then input values. Just in case you needed a little guide for your calculator commands, there you go. Next one. All right, so you may be asked to find areas in a standard normal distribution. What does that mean, standard normal distribution? So we're not talking about like a mean that's some value in the world, right? We're talking about this distribution, right? Our standard normal distribution looks like this. Remember, 0 is my mean. 1, -1, -2, -3. Not very good scaling here, guys. Sorry. Right? We're talking about that. So then what area are we talking about? We're talking about between -0.58, so somewhere around there, and between 1.79, so somewhere around there. So this is the area we're looking for, right? Remember, a standard normal distribution can be defined with a mean 0, standard deviation 1. So easy peasy, I can go to my calculator and do this. People get a little thrown off by that though, because oftentimes they're not sure what to put for the mean and standard deviation, and that's why I drew that picture for you. So let's go ahead and find this area real quick. Normal CDF. My lower bound was -0.58. Upper bound was 1.79. Wow, is my memory good? Oh, wow. That's unusual. All right. And now this is the deal. Since it's a standard normal distribution, not changing these, right? Your calculator automatically assumes that you're trying to find an area in a standard normal distribution, unless you tell it that you're actually dealing with some other normal distribution in something that exists in the world. I hit Kurt. Okay, and I get 0.6823 approximately. Yep. This one works actually. This one doesn't have to be, because it says proportion. I mean, a percentage is a proportion, but also a decimal is a proportion as well. So we're okay with that. And I forgot what my answer was. 6823. Easy peasy. I need to get to. All right. Ooh. Yeah. Like this. This is a good one. Now we're going backwards, guys. Right? Before, we had an X value, and we founded. We didn't founded anything. We found an area, right? Or some sort of proportion for that. Now we're given the proportion or the area, and we need to find an X value that corresponds to that. So we're going backwards. We can do this a number of different ways. I'm going to first use algebra, and then I'm going to do it on the calculator. You'll see which one's easier. The algebra is not bad, right? So what I'm looking for, this is a standard normal distribution, right? So standard normal distribution, it's got that going on with your mean and your standard deviation, right? And then what we're saying is that we have an area of 0.20. And what I need to find is an X value that corresponds to that area. So, right, I can actually get out a little algebra. It doesn't happen a lot during this class. It's going to happen now, though. So I'm going to use this. Hey, look, I got all that stuff. Almost. I got to figure out a z-score for this guy, right? But I do have my mean. I do have my standard deviation. I just need to figure out what z is, and then I can solve for x. That's my plan. All right, so I'm going to go to my handy-dandy table, and now we're going to have to go backwards, okay? So this is how it looks. So if you're given a proportion or an area, and you need to find a z-value, you're going to start from the middle and work your way out. I'm looking for a 0.2. So in the middle, I'm looking for 0.20. I'm going to find a value as close to that as possible. Almost all the time, you're not going to find that exact value. You have to find the closest one. So 0.20 not going to be there. Oh, too far. Okay, here we go. We're close. Where are you at? This one. Yeah, right. I don't see a better one than 0.2005. It's like the closest one. Sometimes they're really close. This one looks fine. All right, so that corresponds to a z-score of negative 0.8, and then I got to figure out what column this corresponds to. It's not in the screen. Oh no. 0.4. So I'm looking for sorry. There we go. Negative 0.804. Okay. That was kind of cool. I didn't even plan that. All right. Negative 0.804. So now we got it. Negative 0.804 equals x minus my mean, which is 0. That'll be easy. Divided by 1. Which one? This? I think on our table it was negative, was it? Yeah.
But 20% has to be above it. So 20%.
Yes. Oh, we're looking for above. Did I not read the question right? Above. Okay, let's do below first. And then we'll look at above. So let's do below, sorry, first. I'm not trying to make it complicated the first time we do it. So that's why thank you though. All right, so all right, 20% of observations above now is going to be corresponding to an area of 0.80, but check it out, guys. Remember, these things are symmetric, yeah? So if I find below, I've also got above, right? Because check it out. I've got this standard normal distribution. We're talking about that this is negative 0. This corresponds to an area. Well, no, wrong. This point, negative 0.804. That gives me an area of 0.20. Well, if that's true, then equidistantly from my mean, I have positive 0.804, right? And that's the same area. Yeah? So if you found one, you found the other. Because that is going to be 20% above. All right, now I'm going to show you the cool way to do it. If you think calculators are cool like me. let's use the calculator now. I want to know the percentage above 0.20. It's the wrong one. All right, so now I'm going to go almost to the same place in my calculator. I'm going to hit menu. I'm going to go to probability. I'm going to go to distributions. And now I'm going to choose inverse normal. Makes sense, right? The inverse, we're going backwards. We're kind of undoing what normal CDF does, almost, right? We're working in a different direction, as inverses do. And what I want is an area. Okay, so now this is where it gets tricky, and you need to think about it, okay? Because if I want the area, I want to know a location for an area that has 20% above, right? That's going to be the exact same location as an area 80% below, right? You know what I'm saying? So that's where I need to be careful. If I put 0.20 in here, it's going to give me that lower area that we had found earlier, right? What I want is I want the location with 20% above. So I'll choose an area of 0.8. And we're not changing that because it's a standard. Whoa, it's a standard normal distribution. I didn't mean to put up that finger. Okay. Hey, we did good. So again, if you're given this problem, you don't have to do, well, I'm going to show you a more difficult example so that we can show you exactly what kind of calculations we're looking for in this. Yes, yeah, you could do that. Absolutely. Yeah, and we'll learn later on. That's called the complement. Yeah, yeah, it's like nice eyes. No, that's the compliment rule. You're welcome. It wasn't weird at all. That wasn't. All right. Here we go. Let's do another one. Rafael Nadal. I don't even, does he still play? All right. Oh, it's so gosh darn easy, but let's go. Let's do an easy one. It says that it's approximately normal. As soon as I see that, I see a mean. I see a standard deviation. And I just write that down so that I can keep track of it. I hate having to read every time I want to try to find a value. I'd rather just see it. Plus, whenever I'm doing a test or something like that, man, I try to write stuff down immediately. It just makes me feel good about myself. You know what I mean? Sitting there staring at a blank paper, it gives me anxiety. I must write something down. Then I feel a little better. I have started. Maybe what I wrote down isn't in the right direction, but I still feel better about having started to write some stuff on paper, right? This is the way I've always worked. All right, so this we want to know what we would expect to exceed 120 miles per hour. So we'll find a t-score for 120. 5 divided by 6. I should know that. Approximately 0.833. All right, now, at this point in time, I'm just going to go to my calculator. I'm not going to mess with the table. I'm trying to do this the most efficient way possible. If the table is more efficient for you, then do that. It's fine. It's for me, the calculator is more efficient. So my answer is just going to be some area. We're going to get that bad boy out. Again, menu. You're going to do this so many times this year, just so you know. Above? exceed, yes. So that means my lower bound is 120. My upper bound is basically infinity. My mean, it said, was 115, guy. And standard deviation was 6. Man, some days I am on my game. Some days I'm not. Okay. 0.2023 approximately. 2023. And we're asked for a percent, so there it is. Context. Remember, be specific, okay? Make sure to always be specific. Put a little extra, you know? Make a sentence out of your answer and all of that stuff. Holy smokes, that went so fast. That's sad. That makes me a sad panda. I don't want AP Stats to be over today. We're not doing that. Ooh, okay, so all right, last one we're gonna do, and then I'll add something a little bit. We'll talk about transforming data and how that affects mean, standard deviation, interquartile range, things like that. But this will finish up the examples. It's a very, very long video. So let's figure out what the third quartile is of the distribution of heights of 3-year-old females. It says it's normally distributed with a mean of 94.5. Oof. And a standard deviation of 4. Fantastic. We want to know what the third quartile is, right? So at the third quartile, what percentile are we at, right? That's the first thing we need to answer. And that's at the 75th percentile, right? That corresponds with an area of 0.75, right? So if I was going to do this algebraically, I would set up my z equals x minus my mean divided by my standard deviation. Problem is that you know, I have to do a little extra legwork to figure out what this z value is, and that's okay. It's actually quite easy to find. We'll just do our inverse normal. We'll have to do it twice. You could just do it once. Yeah, let's get our answer, and then we'll talk about how thorough or not thorough we could do it. So whenever we're given an area and asked for a particular x value, we can use our inverse normal function in our calculator for this. So that you can get by hitting menu, probability, distributions, and now we're going to choose inverse normal. Our area we're looking for is 0.75, right? And we're going to put our mean and standard deviation of the problem, 94.5 and 4. And that's it right there. So a height of 97.198 centimeters is at the third quartile. Pretty easy. So, okay, 97.19. Wow, I know it's 198. That's what I want. And these were in centimeters, right? Yeah, okay. All right, if I wanted to get algebraic with this thing, I could. I can get a z value at that has an area of 0.75 using the same function in my calculator. But actually, sorry, let me finish the finish the calculator approach one. It is acceptable to have all these things and to just put a calculator command. So if you write your calculator command, it was like, so I'm just writing what came out. Oops, and that ain't right either. I'm just writing basically what the calculator command did. Strangely enough, that's an acceptable answer. I really like showing knowledge of what's going on, though, with the formula. I wouldn't mark you wrong if you did it that way. I just like this better. And I think that if an AP grader saw you take that extra step, you'd be more likely to get some points on something that might have been a little more vague. So what I'm doing now is finding a z-value, right, in the standard normal distribution that has an area of 0.75 beneath it, okay? So that's all that does. Turns out that my z-value would be about 0.675. So another approach would be to put that in there. So I put about 0.675. And yeah, cool. And then you could just, I mean, we know the solution of this thing, right? We know that x is 97.198. So you can be extra thorough and take this step if you like. If not, that's okay too. I just like to show you all of the approaches, right? You could even solve this thing for x if you didn't want to go through doing the inverse normal calculation on your calculator. So that's it. Oh my gosh, that was a lot of examples, like a lot. Thanks for, if you watch this whole video, wow, you're pretty amazing, pretty fantastic, fabulous. Yeah, maybe even fabulous. All right. So thanks for watching. Hope you have a great day. If you're not having a great day, smile at somebody. Maybe you'll make their day better.